This is Cafe CLIL, number 12, The Language of Mathematics, Averages, recorded on June 15th, 2010.
And we're going to talk about maths, and I chose very randomly actually some pages to do with averages and data handling, and I posted them on the FactWord website. I wondered if you had a chance to have a look at them.
Yeah.
Okay. Well, we've had discussions before about specific content from specific subjects, namely geography and science, and we had a very rough procedure in those two discussions where we had a look at the language generally of the subject. We discussed some specific material like this, or it could be some other area of maths if you like, and we talked about what language we could identify within that area and what demands it may place on students working in English as a second or foreign language, additional language, I've been told recently I should say. And the third thing, if we could make suggestions about supporting those learners doing this subject in English as an additional language. Is that okay with you all?
Yeah.
Okay. Right. I mean, I'm very open to if anybody wants to jump in immediately with a reaction to the materials or a general comment about the subject. I mean, I've got ideas of my own, but I don't want to dominate, you know. Any comment? I mean, I'm also a little bit sensitive about pulling Sandra straight in as our maths expert. She might feel as if she's been placed in centre stage if I do that.
Yeah.
I don't mind.
I mean, we've got John and I have worked recently on a project working with maths teachers who have been trained to teach through English, and this area, the data handling and averages, is something I used on that project. I wondered if have you worked on this area of maths before, Sandra, data handling and averages?
I did.
And did you do it in English?
I did. I tried to do everything in English.
Yeah.
If the eyes of the students get bigger and bigger, I switched to German.
Oh, that's a very useful message that they're sending you if they broaden their grin and widen their eyes. That's a message that they don't understand.
Yeah.
I mean, if I make a start on this particular topic, the first thing that
Pete,
just a second, let me add in. I was going to say the first thing that came to my mind is that there's quite a lot of subject-specific language, a lot of vocabulary, for example, like the different types of averages. That's one thing we could talk about. I'm bringing Peach in now while I'm trying to talk to you at the same time.
I mean, one of the things I find difficult with maths is that a lot of the language is actually not sort of hidden. You know, it's because there's a lot of symbols. You don't actually know what the language is. I mean, if you look at, I'm just looking at this first page where it says example 1, and then there's a mass calculation, you know, mean, calculate the mean. Now, the language of that, I can work out what the language of that is because I did my school maths, but I mean, it's not on the surface of the text, is it?
Are you talking about the first page, John?
Yeah, where it says example 1, find the mean, mode, median, and range for this data.
Yeah.
And have a lot of calculations. And a lot of the crucial language is actually in the calculation. But it's not on the surface of the text.
Yeah. You find quite a lot of that language when they give examples along the margins or down the margins, don't you, where actually explanations are written in on the page.
Well, you do a bit, but I mean, it's going to be like 12 plus 7.2 plus 8.6 plus 7.5 plus 10 over 9 equals 3 plus 7 over 9 equals 9.3. You know what I mean?
Yeah, no, that's not there, yeah.
All that stuff Or even more complicated on the other side, special notation for finding the mean. Using this notation, mean equals x1 plus x2 plus x3 plus, etc.
That's page 351. I'm sorry about jumping in all the time, John. I'm trying to. I printed these off and I'm looking at them. I'm just making sure everybody knows where you are.
I'm on the first page, the first double spread of your, your 2 pages.
Yeah. So you're talking about procedural language then, aren't you?
I suppose I am. I don't know what you'd call it really, but
it's a language of solving a problem or solving a question or going through the steps of finding an answer to a question.
Yeah. How do you put calculations into language? How do you actually make calculations? How do you express calculations in language?
Yeah.
And I have to work it out. I don't know exactly I don't know what the language of velocity calculation is. I have to work it out. And sometimes I can work it out because it's simple, but other times I can't work it out at all because I don't know it,
Yeah. I placed myself in the chair for this discussion, but please do just jump in with reactions, and because my first response to John's comments is I want to talk to Sandra to find out what she thinks. Well, how do you provide that language in a maths lesson? The language of explaining how to solve the calculation.
I think math, not depending on the language you're talking about, it's always about arranging numbers and getting text into formulae or into equations or a combination of numbers. So, for example, the example 1, so A, the mean needs to be calculated. Somebody would say, if you sum up all the numbers you have written down, or it's given in the example, and you sum them up, and you divide them by the amount of all these numbers, you would get the arithmetic mean.
Yeah.
This is what, but a few folks don't understand even in the native language.
Yeah.
Because it's abstract.
Yeah. But what you're saying, what you're doing is you're giving an instruction or an explanation of how to do this. You're saying, if you do this, you get this.
Yeah.
And I think that's one thing, an explanation of how to do something in there is one thing. But the other thing is actually doing the calculation out loud.
You want a 12 plus 7.2.
Yeah.
So, we are counting together 0.2. And 7 plus 12 is 19. So you want us to come up to do everything step by step. Did I get you correct?
When I ask myself what's difficult about doing maths in a second language, there are various things, and one is explaining things like you just did. If you add up all these things and then divide, etc. But the other difficult thing, which is a very different thing, is actually doing the calculation out loud. I'm just thinking of what makes it difficult to do maths, and there's at least a couple of things there.
There are two things, are there? You're looking at the actual bits and pieces of the solution, and Sandra's explaining language to do with describing the steps.
Yeah.
Aren't they?
Yeah.
May I jump in?
Please.
For example, I'm not an English teacher, and I am language teacher. I read these pages, and I have no problem in understanding. But if I should read these pages, I would not be able to. I'm not able to express what is written from a mathematical point of view. I don't know if I am clear. I have no problem in understanding what is written there.
Yeah.
both from the conceptual point of view and from the language point of view. But I can't
Express it.
I can't express it.
Yeah.
And I think this is your point, John. Or
Yeah. I mean, absolutely. Yes, it's to do with expression. I think it is to do with expression. For me, it's to do with expressing these things. On the other hand, I did have a problem with understanding some of this mathematics. I think there is a comprehension issue as well. I'm sure for all kids learning in the second language, there is a comprehension issue as well as an expression.
These papers are not very great. They are very. I would never give these papers to students.
Oh, really?
No, because.
Why don't you like?
For example, if you just look on example 1 again, the A and C is written very small. What really the context is of the word means. What does it stand for? You just take a calculation, you get the number 9.30. Let's say, what is it? But it doesn't say, just a little sentence that it is arithmetic mean, or the mean which is goes to the middle. Doesn't say anything.
Yeah.
It doesn't sound very well, does it?
There's no
already.
Yes. If you don't know, you just have a number. For example, if you just make a graphic where you sign every pound and start a count and a point, the students get a feeling where is the middle of these different numbers.
That would be a good way, wouldn't it?
Yes.
May I put this
Pete, welcome. Go ahead.
Thank you. As a language teacher and as somebody who was absolutely awful at maths, I personally found the explanations in this example very helpful. I personally think that once students grasp the basic mathematical vocabulary like plus or minus or over or whatever, and if you take them through examples like this repeatedly, step by step, I think the concept can become clear. I'm not too sure whether you agree, but that's what I personally think. What the difficulty for me is, the mathematical language, as long as it stands as it is without having been explained to me, I personally find it very difficult to off the cuff say what is the mean, how do you calculate the mean or not. So in that respect, I found myself as a complete novice and in the same position as a student.
Yeah, I mean, I think we all think like teachers, and when we look at what's on the page, we immediately begin to think about all the other things we do in the classroom. Like as Sandra quite rightly said, you want to be able to visualize it in some way to make the abstract word mean more concrete for the learners, and I think that's very true and relevant, and it's probably true for all of those abstract concepts in the whole of this unit.
Yeah, and personally I think what would be helpful to me is, I personally think this page here is a total overload, but that's because I'm afraid of maths. If you lift just one calculation out of the page, put it on a board, whiteboard, blackboard, or interactive whiteboard or so, that would be much more helpful to me.
Yeah. I think also in terms of CLIL, in terms of working through an additional language, that's always going to be true, isn't it, Peach? That you have to break down the dense content that's on the page.
Yeah.
And obviously we don't have a concrete classroom to work with as an example, as a context for discussing this, but by and large it's a very good principle, isn't it, that you have to break things down into simple chunks to start with.
Yeah, and sort of try and blot out the whole sort of context in terms of print which is around one single calculation. And I guess that's true for, as you said, any other field topic which is difficult.
And the way we usually go with this, Pete, I was just going to say that I usually try and tempt you with an outcome, a carrot for an outcome at the end of our discussion, such as a list of principles, and I'm making notes, and I will put them all in the minutes of our discussion on the web page. And I think listing out problems, visualizing them on the board, maybe while the teacher's explaining step by step, you might even annotate the steps of the solution with key phrases, the kind of language that John was concerned about initially.
Yeah.
And in a way that in a language classroom you might take for granted, where the teacher might choose a stronger student to repeat a line of a solution and ask other students to call or repeat. I'm not sure if math teachers would welcome that kind of work, but I think in a math lesson in an additional language, that repetition work is very useful.
Yeah, definitely.
This session is this chapter because you have to integrate the number which you receive when you do the calculation.
Say that again, Sandra?
You have to integrate, in this chapter we have to integrate the numbers.
Yeah.
You have to know what does it say. Is it a good number, or can we make special conclusions out of this number?
Yeah.
Or is it worthless?
Yeah, I see what you mean. I mean, the other thing that struck me, apart from just the vocabulary, the specific terminology, were the everyday applications. I searched through the unit looking for hints of where it might be useful in everyday life, and the key concepts, the key terms that jumped out to me, and I wrote them down, were scores and amounts and heights and results and prices, and they all give hints to where calculating averages and comparing whether certain averages are better than others might make sense. I think about my father, for example, who used to run the darts and crib league in the district of Oldham where he lives. He used to create the score tables every week for the local newspaper, and I imagine the kind of thing that's going on here, he probably did quite a lot with the numbers he was working with in the darts and crib league in the local newspaper. But that doesn't jump out immediately from the unit unless you look for it, what the everyday application is for learning how to do this particular area of maths.
Yeah. But sometimes you get applications in the examples, don't you?
Yeah.
One thing I think about maths is that the quality of teacher talk is extra important. If I open a science text, or if a student opens a science text, you can normally work out from the page, if you look carefully, what is being taught. You can, you look at the visuals, you read the text, and you can roughly work out, even if it's new material, you can work out for yourself what's on the page. I think kids can do that, and I can do it as a non-scientist. But if I look at a maths textbook, I think what's missing, and what's really vitally important, more than in science or other subjects, is the quality of the talk that the teacher uses to go through one of these things, one of these calculations on the board with the kids. It becomes extra important in a way that is not necessarily the case with other subjects.
I would say you need a story behind the numbers, and then the kids know how to do it. If you just look on the numbers, I'm absolutely with you, and I agree to you that a math book is a horror. And I really would appreciate if there is a nice story behind everything, or getting them to usual day adventures or something like that.
Yeah.
Even all these examples and problems which are written down over here, they are not the problems of students. So just pick them up, go ahead, and to feel with the numbers. There's just one with the height of the pupils or the students.
Yeah. That's right. I mean, we don't know what's in the teacher's book, do we? Because I don't have a copy of the teacher's book to go with this. I mean, we would hope that there would be hints for the teacher in the teacher's book to contextualise what goes on the pages here of the student's book. And it may be, Sandra, that there is some kind of warm-up around the activities on these pages. I don't know. And I agree with you. I think you're absolutely right that each and every one of these, it's so dense, as Pete said, needs taking out and contextualising in a real-life context for the learners.
I think the idea that Sandra has come up with, trying to integrate these figures into a story, is a kind of visualization for the students, and it makes it easier for them to relate to these abstract concepts.
Yeah. What? Go ahead.
Just one more thought. I thought about the implications for teacher training and, above all, CLIL teacher training. And I think what John said before is very, very important. How do CLIL teachers, especially non-native teachers, get the language to talk students through these problems? And it's vital that that kind of language is something which maths teachers are familiar with.
Yeah. Technique I've come across, which sounds quite interesting, is getting the children to interpret what they see in a task on the page in their own words, and then moving them from their own linguistic interpretation to the language of the teacher, to the language of the subject. And that middle ground, if you like, between what's in the subject and the content language is seen as an essential step for them to take. Interpreting what they are presented in their own words before being expected to go into the language of the specialist, if you like.
Yeah.
Sandra, you were going to say something.
Yeah, sorry.
Go ahead.
I was just thinking about the horror thing on page 353.
Yeah.
And the example 9, there is a diagram. It seems to be something like numbers 0, 1, 2, 3, one above the other, and then zeros and whatever. And it says beside this that and these diagrams. I have never seen this before, and this diagram even needs to be explained for the students, I think, for 1 week, to read it correctly, and that it goes into the brain, and be able to read it in just 1 second. So I really absolutely agree with all these people.
Yeah, it's very dense, isn't it? I mean, the stem and leaf diagram, the idea of creating diagrams around these numbers is a whole new dimension, isn't it? Apart from simply understanding the concepts and working with them.
Yeah, I had to look through it just to get what does it all these mean, because it has different numbers.
Yeah.
And to know which it says about the temperature, and to know that the temperature is 90 degrees. It took me quite a long time, so the students, if they're even afraid of math and you teach them this diagram, I think they wouldn't like it very much.
Yeah.
I think it presupposes a lot of knowledge. I mean, there's a little section, a little note, look back. I think it presupposes that a lot of stuff has already been done. Maybe.
I don't know which level these books are. For which level these books are done?
Well, this is for it's an O-level textbook. It's a higher O-level textbook as well.
So the pupils are about age 12, 14?
They'll be 15 and 16.
Okay. Yeah.
Yeah. I mean, the other thing that occurred to me when looking through this unit was, there isn't really any interaction, is there? There isn't any hint of what might be going on between students while doing these tasks. They're all they all look to be individual tasks in a way that, I mean, what's on the page is directed to individual students rather than anything happening with the learners in the classroom.
But isn't that typical of textbooks in general? You know, like if you had a science textbook.
Well, I think it might be for content textbooks, John, but not necessarily with language textbooks.
Okay.
You know, the instructions are there to work with a partner or share with the class.
Yeah.
And I wondered, is it worth us? I'm not really saying that to criticise the book because we could spend all our time just doing that. But I wonder, in terms of developing language for this subject, for this topic, exploring how students interact with each other might be worth discussing, because if they're asked to carry out a survey of heights, for example, which I think Sandra was referring to, then they've got to go and measure people in the classroom and then report it back in some way, orally, or write it down, or present it. All of that is another very important dimension of the language of maths, isn't it?
I did this chapter 1 with the class, and I did it in a way that I formed 3 groups. One gets the most, one gets the medium, and one the mean. And all of the group in itself some examples for this, so they get familiar with just one term. And then the changing in the group and try to give information forward to the other students. So the students talk to each other in their languages, which is sometimes easier than the language of the teacher.
In their first languages?
Mostly the change to the native, to the first language, but sometimes the students speak English. It's depending on the class.
Yeah.
And when you say their own language, you mean in their own words then, Sandra?
Yes.
Yeah.
Okay.
Yeah.
Because the sentences are easier, the structure is easier, and the words they're using are easier.
Yeah.
This works quite good.
Yeah. There are lots of different levels, aren't there? There's, kids talking informally in the way you're talking about, where they use their own words about calculation.
And they concentrated on the point and not on the surrounding. We have a bigger surrounding around all of the whole chapter. We know where we aim to. They just stick to the point what they have to do now.
Yeah. And there's also kids talking more formally about it in the language of math, as you would expect it, in the public classroom or used by the teacher. And I think actually there's also kids talking math in their first language. I think a lot of the calculations kids would like to do in their first language. You know what I mean? And I mean, I think the use of the first language is very special in maths in a way which it isn't necessarily in other subjects, because calculations, it's so much more easy to do calculations in your first language and so much more difficult to do the calculations in your second language. It must slow you down enormously to have to do calculations in your second language.
Yeah.
I don't agree with this, sorry.
You don't?
No. In my experience, there is no slowing down, because I think even my language is not so difficult anymore, because I don't have every word ready to have talk about it.
Yeah.
So I stick to the main problem, and I stick to almost the same sentences, and I repeat myself very often, which helps the students to get more and more familiar with this terms.
Yeah, I'm just thinking of a student doing the calculation themselves. If you ask a student to do a first calculation like 12.7 plus 7.2 plus 8.6, that one at the bottom of the first page, where it says me, plus 7.5 plus 10 plus 7.5. If I was doing that, I would want to do that quickly in my first language, in my head. You know what I mean?
Yeah, the head is working here. You're right.
Yeah.
That level of quick calculation, I would like to do that in the first language, and then maybe I could explain it in the second language.
Yeah, that's correct.
Isn't that
That's the level I was thinking of.
Sorry, John, isn't that just a question of practice? If you do it often enough in L2, or L3 for that, it will come automatically.
I don't know. I honestly don't know. I don't know. I wonder whether people who are very fluent in a second language would actually prefer to drop back quickly into the first language to do calculations, and then switch back into the second language to talk about those calculations.
I don't know whether it's...
do the calculation.
Yeah.
Go on.
I was just going to say, for the record, on the Fact World website, there is an article that deals with this very question, called Using Two Languages When Learning Mathematics, and it talks about the language of preference and whether being asked to work in an additional language slows down maths solution time. And I think the results show that it does. With bilingual learners, Spanish and English, for example. I'll put a link to that in a minute, so that anybody interested could go and have a look.
Oh, thanks.
Sorry, John, I interrupted you.
No, I'm just saying that would be good. It would be good to see that. Not by a woman called Moscovich.
Yes, it is.
Yeah, I wondered. Yeah. I mean, I do find that math is just a different thing from other subjects. As a as somebody who's not a subject specialist at all, it's much more easy for me to see the language demands that are made by science or made by history or made by geography than it is to see the language demands that are made by math. And I think part of it is that a lot of the language is not on the page. A lot of the language exists between the teacher and the student.
But don't you think, though, that there is an issue here that teaching maths in an additional language becomes a different subject, doesn't it? It's more than just teaching maths. It's about teaching the language as well as the maths. And I know, we could say that applies to CLIL generally, but I've come across people writing about maths with bilingual learners and specifically using the subject as a springboard for developing language. And I think that's really what we're all about and here to talk about is what that new subject is. I think it's more than just maths. It's how you anchor the language onto what the students are asked to do in the maths.
Yes, definitely. And I personally think that goes to show that any kind of teaching is also always language teaching, because it involves language. Yeah. And I personally think that teachers who teach any subject in their mother tongue, to mother tongue students, are very often not aware of that fact.
Yeah. I'm going to drop in the name of this book that I was thinking of while I was rambling on there a little bit. It's called Teaching Mathematics to English Language Learners, and it's a Routledge publication from the US. I've written a review on it with links that are in the book to projects in the States that are about developing language of bilingual learners of maths. And I'll put that in there, so there's a link to that as well, because there are some very useful scenarios and cameos of schools where teachers are doing this, and they're very positive stories. That's why I'd like to put it in there. Success stories.
Yeah, that's very useful.
But just thinking back to the time when I started with trying to be bilingual in mathematics, you are absolutely right. The biggest problem was to read everything. For example, if you have cube weight is 3 times 8, I couldn't read this because I wasn't familiar with all these terms and language behind the math. I could not read it, but not speak it. say,
Okay.
this was...
But read it and not speak it.
Yeah, that's correct, yeah.
Yeah.
As the students, when we teach the students again, they already get the information. So I think it's for the teacher even harder to understand as you get through mathematics text and try to speak, read and speak it, or tell it aloud, than for the students. Because I have never had mathematics in English before. Thanks to the web, it is possible to download a lot of videos.
Yeah.
Videos, you mean people talking now?
Yeah. I did a lot of YouTube, for example.
Oh, really?
Yes, because there are a lot of math lessons on it. Where I understood the concept, but I didn't know how to express an antiderivative or something like this.
Right.
Yeah, this was one of the hardest stuff for me to get used to all these languages or language.
Yeah.
And I think the quality of somebody talking now on the internet, for example, it's just a very different thing from looking at this page. It's a different linguistic experience. It's a different variety of language. And it's crucial for the kids to understand it. It's crucial for the kids to hear teachers talking about math problems and going through them on the board.
Yeah. I wonder, Sandra, when your students have to sit exams, are they expected to produce any sentences in the foreign language, or are their exams, their maths exams, questions very formulaic and symbolic, or do they actually have to produce any full sentences?
My students, no, but they do an exam or did an example? I didn't get it correctly.
When they do a test or an exam.
Okay, yeah. When I'm going to test them or do an examination, everything starts in English, but when they have problems, I try to explain in German again. And I always, sometimes they even know more often the English term for this, because I repeat it more often than the German one. I think that is not really difficult for them. And I never had any student of mine who say, who complained about English, it's difficulty of his mark, but at least they failed because they didn't do well because of the time management or something like this.
But your students don't struggle with producing full sentences in English.
No.
I mean, if I show you an example on page 355, number 2 and number 4, and number 2 has numbers of parked cars, and the students are asked to find the mode, the median, and the mean numbers of cars parked, and then comment on their results. And that's the bit that took my attention, this comment on your results. Which would be the best average to use? So in order to, they can't just give a number, they have to give a full expression of some kind.
I think they would ask people to work it out.
And then number 4 is explain why. So in order to explain why this statement could be misleading, to be able to give that explanation in English seems to me to be more difficult to mark than just a number. And that goes without saying, obviously, because the number's either right or wrong in most situations, I imagine. But giving an explanation why the statement could be misleading, to what extent the model answer is flexible to include all the answers the students might give when they write down their answer. Because what did he say? The average score for a batsman during one season was 17 runs. We don't know whether it's a mode average, a median average, or a mean average. I suppose that's what could be misleading. So for a student to be able to write that down, the kind of sentence they could create to be able to say it, is very varied, I think, and that's my point, is that there isn't just one answer, is there, to give that answer?
Yes, I think everybody has its own answer, and you have to accept it. That it's different in math what is a number and what is his opinion or conclusion out of this number. Especially in this chapter. Sometimes there's there's not only one answer to this question.
Yeah.
Mike, can I give you another example? I'm looking at Keith and I have been working on this. Keith was saying, teachers of maths in Qatar. I'm looking at a maths question in Qatar. It's very simple. It says, which is smaller, 5 over 16 or 6 over 17? And it would take me quite a long time to work that out, but it's quite easy for a student who understands that kind of thing to give the answer, wouldn't it? You just give a number. You just say 5 over 16 or 6 over 17, and you do all the work in your head or on paper. But then after that, it says, explain how you know how. So it says, the question again is, which is smaller, 5 over 16 or 6 over 17? And the language demands of that are minimal. The mathematical demands, I think, are probably quite high, but the language demands are minimal. But then it says, explain how you know how. And I think the language demands of that are very high.
Yeah.
And the mathematical demands are very high as well, the cognitive demands are high. But students have got to do both those kinds of questions, haven't they?
Again, I personally guess, I don't know, but I guess once a student has grasped the concept, it will be easier to do the mathematics in his head, but then quite difficult to verbalise reasoning, giving a reason why he thinks one is smaller than the other one.
Yeah. I mean, partly it goes back to what Sandra was saying about expression. You know, you can understand a lot, but it's very difficult to actually express it.
Yeah.
And I think the crucial thing about helping students to express things is the quality of the talk that goes on between the teacher and the class. If the quality of that talk is really rich and expressive, and students get to hear a lot of maths talk and pick up a lot of maths talk, I think the teacher might then be able to do the explaining themselves. But if the quality of talk is poor, then I think that would make it very difficult for the student to do the activity. They'd be able to do it in their first language, they'd be able to do it in their head, but they wouldn't be able to do it in their second language.
Definitely, and that's why teachers need to be aware of the kind of language they have to use to talk students through problems like these, and to do it multiple times so that the students become accustomed or familiar with the kind of language which is then required of them to explain themselves why they arrived at a certain result.
Yeah. I mean, I must say, I looked at lots and lots. We're partly talking about testing here, partly talking about learning, but partly talking about testing. I looked at lots of questions in the Qatar maths exam. Most of them require just numbers to give the answer. They're cognitively difficult. You've got to do a lot of stuff in your head, or in your first language, or on paper, but the answer is just a number. But now and then, you get these more linguistic demanding answers, like explain how you know how.
Yeah, I wonder if that's the same in most countries in maths. I don't know. I mean, I having students write answers in full or write a story. I've seen a teacher in Lithuania ask students to write a story that includes maths concepts like a right angle triangle, for example. But I don't think it's very common.
Well, it depends at what school level. I'm sorry.
Sorry, no, go ahead, go ahead.
Yeah, I think it depends at what school level. Because in my country, for example, at primary level it's very common. It's really very common. And maybe also at lower secondary level. But when you are older, starting from 15, 16, everything is abstract.
Yeah.
But there is really a gap between what is done at primary level and what is done later and how it is done.
Yeah.
There is a real tradition among the primary teachers to develop a history with number and kind of functional numeracy. And later on, everything becomes abstract. And of course, it makes the youth and the learning in a foreign language more difficult.
Much more difficult.
Yeah. It's great. Listen, I'll try and find out a bit of information about that. Maybe collect some samples of exam material and see if there are any, if there's any discourse in maths exam answers expected of students. I suspect not, particularly in the context that we work in. It tends, I think, and I'm generalizing, I know, but as Loretta said, I think secondary tends to be fairly abstract. Listen, sorry, John?
I think that's right.
Well, listen, unless there's something else, because it's 25 past the hour, and we've actually gone through all the pages that I've made notes on, so I've not really got anything else to say. But I would like to thank you. If there is anything else we can tie up with, please go ahead.
I just wanted to ask where you learned your math language, your English math language. How did you learn that?
I already told that I tried a lot of YouTube videos and asked a lot of native speakers if I'm expressing it correctly. And this was the first, most of the first I had.
I see. Did you find yourself translating a lot? You could do something in your first language and then you...
In my teaching, I use the German book, and I take the time and have a very good book with a lot of graphics, because I like graphics. I'm a visualizer type, and these graphics I use and translate in English. And the students get from me portfolios where they have the English terms on it, and they can flip through the book and get the German books and the German explanations if they need it.
I see.
So this is my kind of teaching, which seems to be quite okay for the students.
Yeah.
Do you think it would be useful to have an archive of good, rich but simple explanations of standard maths tasks on video, John?
It would be great. It'd be great.
Wouldn't it?
Yes. There are a lot of them are in the net. Even the simple ones, because I started simple. I started by doing in the head 2 times 3. It was quite difficult. 12 times, how do you divide 122 divided by 25? All the writing and all the things what you learn when you're in primary school, all the things you get in the net, on YouTube, or there are math tutors where they offer these lessons for home training, and these were my classes.
I see. I think that's really important.
Perhaps, Sandra, if you had easily available any good links for those kinds of resources, please do send it to me and I'll add it to the page of notes about our discussion for other people to go and visit.
Yes, I will do it.
Thanks a lot. Listen, let's call it a day. We'll bring it to a close there.